Hi guys, welcome to the channel. So today we are going to discuss about the types of electronic transitions. So if we talk about the molecular orbital theory, then according to molecular orbital theory, when molecules absorb energy, they get excited to anti-bonding orbital from bonding or non-bonding orbitals. So what does it mean? See, we have discussed the energy levels, right? So the energy levels were sigma, pi, non-bonding, pi star, and sigma star, right? Now these were the bonding molecular orbital, this is non-bonding, and these are anti-bonding molecular orbitals. So when molecule is there and it absorbs some energy, suppose it is in one of the bonding molecular orbitals, then it will be excited from this bonding molecular orbital to the anti-bonding molecular orbital. Or suppose it is in non-bonding molecular orbital, then also it can excite from non-bonding molecular orbital to the anti-bonding. So after excitation the electron will go to the anti-bonding molecular orbitals, right? This is according to the molecular orbital theory. Now, if we look at these energy levels, then what are the various transitions which are theoretically possible? If we talk about the theoretical possibilities, so first will be from sigma to sigma star, right? First will be from sigma to sigma star. Now, second will be from sigma to pi star. Third will be pi to pi star. This one. Next will be pi to sigma star. This one. Next is n to pi star. N is non-bonding, n to pi star, and last will be n to sigma star. So these are the various transitions which are only theoretically possible, right? However, these all transitions are not practically possible. Now we will look for the practical possibilities. For that we have some sort of selection rules that we will discuss shortly, but first we will discuss about these transitions. What are these various transitions? So one by one we will discuss each of these transitions. So first up we have sigma to sigma star transitions. So if we talk about sigma bonds, then that means we are talking about the sigma to sigma star transition. So suppose we take the simplest alkane. Suppose we have this sort of an alkane. So this particular bond, this is the sigma bond, and we know that this is a very strong bond, right? And these type of bonds, if we want to do the excitations from sigma to sigma star, then they will require very high energy for their excitation. So high energy means low wavelength, because E is equals to hc by lambda. If we want high energy, then we have to give low wavelength. So high energy means low wavelength. Low wavelength means we are talking about the lower than UV region. So many of these compounds show the absorption, the sigma to sigma star transitions at a very low wavelength below 200 nanometers, right? So if you could recall the previous lecture, then we have discussed the range 200 to 800, right? This is the UV visible range. From 200 to 400 we have UV range, and from 400 to 800 we have the visible range. But below 200, what is there? This is far UV range, right? Or you can say vacuum UV range. To study these high energy transitions, why I'm saying high energy, because they require very less wavelength. Less wavelength means high energy, and to study these high energy transitions, that is below 200 nanometer, we need to operate at vacuum UV region. That means the whole area, the whole path should be evacuated. Why this is so? Suppose we have some sort of a solution in which we have some sort of solvent, and because of that we want to have a peak, or want to have a spectra. So what happens? Suppose it is going to show the absorbance below 200 nanometer. So below 200 nanometer, if we are taking the spectra in a normal environment, so in normal environment we also have the oxygen molecules, right? So we also have the oxygen molecules, and if we look at the structure of oxygen molecules, then what we will observe is they are having non-bonding electrons, they are having pi electrons as well. So below 200 nanometer, we have very high energy. At this much high energy, we also have oxygen molecules present in the air surrounding that solution. So surrounding that solution, we also have the oxygen molecules which are having the non-bonding as well as the pi electrons. So because we are providing very much high energy, these oxygen molecules show various types of transitions from non-bonding to anti-bonding, and from pi to anti-bonding pi star. These transitions are also possible, and because of these transitions, which are going to be shown by the oxygen molecules, they are going to interfere with the original spectra of the sample. So due to these reasons, due to the reason that this oxygen molecules also gets absorbed below 200 nanometer due to the high energy which is provided by the source. So due to that, the spectra we also get some broad peaks due to the absorption of these oxygen molecules, and this is the reason why we have to evacuate this whole path, so that whenever we are taking the spectra below 200 nanometer, there should be no oxygen present around, so that it could not interfere with the original spectra of this sample. So that is why this region is overall very less informative as well. So this is all about how we are going to take the spectra, and what happens if we take the UV spectra for certain molecules below 200 nanometer. And because we are talking about the sigma to sigma star transitions, in these type of transitions we have to provide very high energy because of the strong bonds, right? If we are going to provide the very high energy, that means we are talking about very less wavelength, less than 200 nanometer. Below 200 nanometer, oxygen molecules will be present, they will interfere with the main spectra, so we have to evacuate the whole path. And due to all of these reasons, this sigma to sigma star transitions, these are very less informative, right? So this is all about the sigma to sigma star transitions. In the next video, we will talk about n to sigma star, pi to pi star, and n to pi star transitions, and we will also look at the energy profiling of all of these transitions. And after this, we will derive certain conclusions as well. So I hope till now everything is clear to you guys. So far that's it for this video. Thank you so much for watching.